Hello, ndikulandireni tsiku la lero pamene tikufuna kupitiriza phunziro lathu la exponential and logarithmic equations. Lero muli ndine Cicero Juma. Tinapanga zochuluka kumba ya logarithmic equations. Lero tipita direct kuzimene tikuyeneka kukambirana tsiku la lero. Sabata yatha tinayamba kuona ma rules of logarithmic equations and tinaonako multiplication rule and some examples. Lero tifuna tipitirize pamenepo kuti tuone division rule. Now in the rule ya number 2 ya logarithmic equations. Basically law hiyo imanena kuti the logarithm of a quotient is equal to the logarithm of the dividend minus the logarithm of the divisor. Okay, so that's that, exactly that is being said above. This is about onena kuti if you have a situation like this one, okay, ukunza kuikhazikitsa choncho ndi chimodzimodzi. Or if you have a situation ngati A, ukunza kuilemba ngati chonchi. So ntchito yathu apapa kwambiri ndikufuna kuonetsa unena kuti zona if you have this problem, for you to solve this problem, you first of all have to simplify it kuti ipwere into that form. Okay, so hiyo ndimaitcha kuti division rule. Base ndiyo mweyo, komano you have these numbers dividing each other. So if that is the scenario, you first of all take that one minus that one. So we want to show that here. Right? We want to show that. Tandikale limodzi pamene tupitiriza. So for us to do that, we have to let log base p over q base a to be equal to c. Okay, you can say that. We can also let, remember here we can say that it means this one, we can rewrite it in an exponential form as p over q is equal to a to the power c. Okay, this is base a. Sorry, base a to the power c in exponential format here. Alright, and we can as well say let log base a, log p base a to be equal to, let's say, m. Okay, this one can be written in an exponential form as p will be equal to a to the power m. Showing this, we now need transforming from exponential to logarithmic. Okay, so we can also let that one log log q base a to be equal to n. Okay, this one can be written in an exponential format as q will be equal to a to the power n. So we can label this as equation 1, that as equation 2, this as equation 3. Okay. Yeah, so let's proceed. So we have 3 equations there. Alright. So now, reaching this far, we can substitute equation 2 and 3 into equation 1 into 1. Okay, we can substitute. You see here, we have p here as a to the power m. We have p there. We have q there, a to the power n. We have q there. So pamene pali p tika p uyo, pamene pali q tika q as that one. Okay, So from there, we say that, let's put it like this. From there, we know that we have P over Q to be equal to, and that one as A to the power C. So, but we know that Q from here, P is A to the power M, which means you're going to substitute. So, substitute equations 2 and 3 into 1. Okay, so that's 1. So where there is P, we are going to put, okay, P is A to the power M. A to the power M over Q. Where there's Q, we are going to put A to the power N. A to the power N, which is equal to A to the power C. So we can use indices now to simplify this one. My rows of indices ngati tikugawira mapezo ofanana ndikuti manena kuti A will be equal to M minus N is equal to A to the power C, like that. Okay, so here you apply the rules of indices. It's like that. Yeah, in this case we have mapezo ofanana. It also means applying the same rules of indices. It also means C will be equal to M minus N. Therefore, if we go there, remember we said C is equal to log A P over Q. So where there's C, let's put that. Where there's C, we are going to put log P over Q base A to be equal to, and now where there is M is this one. We put log A, log P base A, log P base A minus, let's go back here, where there is N, it's log Q base A. Log Q base A. Okay, so indeed, this one is equal to that one. We have really shown this one. Let's move on to some examples. Mukangomvetsetsa that derivation zikhazophweka kwambiri kuti muthe kupanga maneuver pa problems amene mungapatsidwe ena alonse exponential and logarithmic equations. So solutions, let's solve them. A, that's saying is equal to log 15 base 2 minus log 5 base 2. So the issue is to express the following as a single logarithm. Okay, so in this case, to have this one using division rule, it means it will be 15 over 5. Okay, it's the same as like that. Following this, you can go color P over Q like that. So we have just done the same here, which means this one will be equal to log plus 2, 15 into 5 into 15, 3. So that's gonna be our answer in this one. Okay, our B, let's solve B. B, they're saying it's log base 10, 175 minus log 25 base 10. So here's something, we're going to simplify this. To simplify this one using rule number 2, we're going to say 175 divided by, in this case, 25 base 10. This one will be equal to, so in this case 175 divided by 25, that's 7. So you have log 7 base 10. So it's as simple as that. Okay, Now let's go to the rule number 3, the rule of powers. Okay, you see, here you have p to the power n, log p to the power n base a. And they are saying this one is the same as to write that. So we really need to show what is on when you have log of that form, you can simplify it into that. Or when you are given that, you can simplify it into that. Okay, so for us to show that, we are going to follow the same process as well. Okay, we can say let log Pn base A to be equal to let's say C. Okay, then you can write this one in terms of exponential. It will mean it will be p to the power n is equal to a to the power c. And you can as well let log p base a to be equal to maybe let's say m. Okay, and this one to write the exponential, it will be p will be equal to a to the power m. Okay, so you can say that's equation 1 and that's equation 2. Okay, let's substitute equation 2 into equation 1. Okay, pamene pali p tikepo a to the power m into that. So that's p. Yeah, okay. So equation 1 we are saying p to the power n is equal to a to the power c. So if we put p, if we substitute a to the power m, so to have a to the power m in bracket pamene okhala p to amene taikapo that one. In this case, yeah, in this case it will be p, then we'll put n there. This one should be equal to a to the power c. So my rows of indices, they are multiplying. We can just expand out. Okay, like that. This one should be equal to a to the power c. Okay, in this case, okay, let's take this one. Should come here. Sorry, because of space. So it means we have a m n is equal to a to the power c. So we have the same bases, which means m n is equal to c. Okay. Now, from our problem, remember we can as well write this one as c will be equal to m n. Okay. So let's do that. C we know the log p to the power n, in this case base a, should be equal to m. We know that we had let m to be log p base a, be log p base a. In this case, we can say n log p base a. Okay, which is the same like that one. So, indeed, if you are given a problem like this one, you can simplify it as that one. We have shown it here. Let's have an examples. Okay, in this case, we are given this scenario. So the idea is to express this one into a single, we need to express it into a single log. Okay, so this one, we know that this one can be simplified as log base 5, 3, in this case to the power 2. Alright, if we are to go by what we have shown, in this one can be simplified as log base 5, 2 to the power 3. So it means this one will be equal to log base 5, 8 plus log 8. All right? No. Here it's 9, not 8. Sorry. It's 9. 3 to the power 2, that's 9. 2 to the power 3, that's 8. Okay? All right, so guess which rule is this one? Let's show it. That's multiplication rule. This one. But since parting is zero, you can as well write it like that. Okay? So let's go and do that one. Okay, so these ones, the parts which we're going to use multiplication rule. Okay, so it means this one, they have a base of 1 and a 5. So that and that, it will be 9 divided by 8. Okay, so if you do that, now so 9 times 8, that's 72. It will be log 72 base 5. Okay, the same we can do with that one. Okay, so it means you have log base 10 3 minus, and that one will go there. It will be log base 10, that's 1 over 4 to the power 2. Okay, I will simplify that one. So it means maybe if, okay, fine, let's simplify that. It will be log base 10 3 minus log base 10, that's 1 over 16. Okay, so if we simplify this one, subtracting, which means it will be log, we are subtracting base 10, so we are going to divide, so it will be 3 divided by 1 over 16. Okay, so this one will be equal to log 10, 3 divided by 1 over 16, it will be 3 times 16, which is 3 times 16, that's 48. Okay, so if you want to simplify that into a single form, that's how we do it. Now, let's do this rule. The base and the number are the same. Okay, if you have base and that one number, if they are the same, they always give you 1. They will always give you 1. All right, they will always give you 1. So we need to show that. We need to show that. Okay, so let's show. We do the same. Let log base a, log a base a to be equal to, you can give it any number. Let's say n. This one can be written as a will be equal to a to the power n. So from there we know that, but okay, let's say they have the same base, which means a, we are saying a, let's go to a to the power n, same base. Remember, that one is the same as to say that if you have same base, it means the powers are also the same, which means n will be equal to 1. Okay, so we're going to substitute. Okay, we're going to substitute. Remember, that's n, so we're going to substitute this into that equation. You have log a to be equal to, where there is n, we put 1. Indeed, log a, that is equal to 1. All right, let's have a look at an example. Okay, let's try this one. On this one, you have this one. We're going to apply a number of rules. The division rule, it means we are going to have log base 10 150 divided by 15. Okay, then that one will be equal to log 10. If you log 10, we have proved that it's 1. Okay, yeah, basically that's that. So we have to take that one out. The logarithm of numbers of the same base is always 1. Okay? Base and number, if they are the same, they give you 1. Like that. It can be anything. 1,000, base 1,000, it will still give you 1. Okay? Then we have this rule, the log of 1. Okay? The log of 1 is always equal to 0. That is another thing you have to know. So let's show it, if it is true. So the same thing, we read log a1 to be equal to n. Okay? Then this one can as well be written as, in an exponential form, as 1 to be equal to a to the power n. But 1 can be written to base a, to have base a, is the same as to say a to the power 0 is equal to a to the power n. Okay? All these are rows of indices. It means if we have the same bases, the same powers were also the same. So n is equal to 0. So we're going to substitute n into our equation. We will find out that we have log a1 to be equal to 0. It's just like that. So the logarithm of 1 is always 0. You have to know that. Okay. Yeah, so reaching this far, I think for today, let's stop there. We'll see you again next video.